Welcome to the third part in the series of videos on household circuits, and in this video we're going to talk about a very important concept called fuse. You'll find fuse everywhere in your house. Towards the end of this module, or towards the end of this video or the next one, I promise to share with you an interesting story or interesting prank that children play in hostels, and yeah, I hope you will enjoy it after you understand the theory. Okay, so let's start with a simple bulb. So here is a simple bulb. You will find that this bulb has 2 points. One is here, and the other one would be here. And also the socket also has 2 points, one here and the other here. This corresponds to the live, and the live of the socket is connected to the live wire, and the neutral is connected to the neutral, and this is your neutral, and this we know is about 220 volts. And to understand how this whole connection is done inside a house, so let's assume that this is your house, and you have these two lines coming in. One is your neutral, and then the other would be your live. So to make this connection, we tap a wire from the live and we connect it to a switch. A switch is usually represented by this, and this is switch in the open position, and the other end of the switch we connect it to the bulb. So let's draw the bulb. So this is the bulb which is there in the wall. There's a filament. So we take one end of this live and connect it to one end of this bulb, and this would be your live, and the other end would be connected to the neutral, right? So when I draw it like this, it means it's not touching the live. That's what it means, and this is your neutral wire. All right, so let's close this. Yeah, let's make this look like a house or a building. Okay, and when you switch on, then this bulb will glow. And if this bulb is 220 watts is a power, then the current that it will draw is given by P divided by V, and V we know is always supply voltage is 220. So 220 watts by 220 volts is 1 ampere. So that's not bad. You will be drawing in a current from the live, and of course it goes both ways, of 1 ampere of current that's flowing through the bulb. Now let's assume for a moment I do something really stupid, right? I take a coin and I put it inside this bulb holder, and then I fix this bulb. Oh, before I do that, let's calculate the resistance of this filament. So what is the resistance of this filament? That can be got, you know your V, your V is 220 volts and I is 1 ampere, so R is V by I, which is 220 volts by 1 ampere. That's 220 ohms, right? So that's the resistance. So you connect a 220 ohm resistance across the 220 volts, you will get 1 ampere, right? So that's what it means. So now I put a coin and then I plug in this, I put in this bulb, right? I put in this bulb after I put this coin. So I put in this coin and then I put in this bulb, right? Now suddenly what you find is we call this shorting. So we have shorted the live and the neutral. This coin has a very low resistance. Let's assume that resistance of that coin is 1 ohm. So if the resistance of that coin is just 1 ohm, and here the filament doesn't matter because you kind of connected these two ends with a coin which is 1 ohm resistance. So let's assume this is your coin which is 1 ohm resistance, and you are supplying 220 volts. As per Ohm's law, you will be drawing out a current of 220 V divided by R, which is 220 volts divided by 1 ohm, that's approximately 220 amps. That's a huge amount of current, right? In your home, I mean, with this kind of current, this is enough to entirely melt your wire or kind of burn all the wires, this kind of current. And of course, your transformer can supply a maximum of only 100 amps. So what do? To protect yourself, you introduce something called a fuse. So a fuse is something that what you do is you have this live wire coming in. So to protect yourself, just before the switch, you will put up a device called fuse, and a fuse is marked like that, and this fuse is connected. And well, let me finish this drawing. Yep. Yes. So you have this fuse, and this device has got a current rating, right? We say the current rating is 1 ampere. What that means that it draws 1 ampere of current. The current rating is a max current drawn by device. So that's your current rating. So we put up a fuse, with a fuse rating greater than current rating, right? Which is, for example, I'll put up a fuse of, let's say, for a 2 amp fuse for this case. Now, what is the function of this fuse? When we assume that the fuse is here, right? In this line, the fuse is here. The fuse is before the switch. So I have this fuse. So assume that I'm trying to draw 220 amps, and this fuse will melt. This fuse, if it is a fuse with a fuse rating of 2 ampere, then for current greater than 2 ampere, the fuse will melt, and the circuit opens up, and the circuit is open. So here is a summary of this whole module. So a fuse is something that protects your wiring inside the house. So we say it protects the wiring inside the house, and we don't say that it protects equipment, because let's assume that you have you have this a fuse, and here there's a switch. Sorry about the color coding. I usually, or maybe let me use the yellow color, which doesn't relate to anything. So let's say this is a fuse, and then you have the switch, and you have this bulb, right? So you have this bulb, and this is live and neutral, right? Now when the switch is closed, the reason why you're drawing excess current in the very first place is because there's something wrong that has happened on this device. That means that it got short circuited between live and neutral or something like that, which kind of brought the resistance so low that it tries to pull a lot of current, right? So that's why this fuse breaks up. So your objective is not to protect the equipment really, because your equipment is already faulty, right? So basically your faulty equipment draws high current, right? That's a problem you have. But what you're trying to do is, when this breaks up, when the fuse breaks up, you are actually protecting the whole wiring inside your house. Otherwise, all the wiring that brings in your current, see all this wiring that brings in your current, they all are at a risk if you're drawing too much current. So it basically protects the wiring. So fuse protects the wiring inside the house from overcurrent, excess current drawn due to the faulty device. The fuse rating is defined as a max current that the fuse lets through. So let's say, for example, the fuse rating of this can be like 5 amperes. So your wire is protected by ensuring that you don't draw more than 5 amperes, right? And beyond 5 amperes, the fuse will break open. And the last thing is fuse is always connected before the switch. So the first comes your fuse, the second comes your switch, and the third comes your bulb in the sequence of connections. And the reason why you do that is because you don't connect fuse in the neutral, is because you want to protect the equipment, and the current is actually coming through the live, or it's the neutral is zero potential, and the live is either high in the positive direction or high in the negative direction. So you want to cut off the live, and that's where the fuse comes in before the equipment and the switch. So I hope you enjoyed this video. See you in the next one.